In this video, we're going to be finding the derivative of a function from first principles. That means we're going to use the limit definition to find the derivative, in this case, of the function f at x equals the square root of 2x plus 3. And then we're going to use that derivative to find the slope of that function at x equals 3, and eventually to find the equation of the tangent line at x equals 3. So we start with the limit definition of a derivative, which is f prime at x is equal to the limit as h approaches 0 of f at x plus h minus f at x over h. This is an equation that you need to know by heart. From there, we can substitute for the f's. We already know that f at x is the square root of 2x plus 3. And if we know what f at x is, we know what f at everything is. So f at x plus h is just the square root of 2x plus h plus 3. In other words, we substitute x plus h wherever there's an x. So this becomes the square root of 2 times x plus h plus 3 minus f at x, which we already know is the square root of 2x plus 3, divided by h. Now, if we substitute h equals 0, and for this we discover that we have 0 over 0, which is not at all surprising. We expect that because this is taking the limit as the run goes to 0, and as the run goes to 0, of course, the rise is going to go to 0 as well. So when we have a 0 over 0 form, we look for a technique to deal with that. In this case, we can multiply by the conjugate. And so we're going to multiply, in this case, by the square root of 2 times x plus h plus 3 plus the square root of 2x plus 3. And of course, we can't change it, so we have to multiply by that over itself, so that we're effectively multiplying by 1 and not changing the equation. And we see that good things will happen now. Our limit becomes the limit as h approaches 0. In the denominator, let's do that first, we're just going to have h times this thing on the right. So h times the square root of 2x plus h plus 3 plus the square root of 2x plus 3. And in the numerator, we're going to apply FOIL to this. Essentially, we treat this as the product of a binomial. So the firsts get rid of the square root, and we're left with just 2x. I'm going to multiply through here. I'm going to get 2x plus 2h plus 3 minus, and the inners and outers will cancel, and we're left with the last, which is going to be minus 2x plus 3, like that. And we can do some cleaning up here a little bit. We can see that some of the stuff in the numerator is going to get better. So now I'm going to have the limit as h approaches 0 of, let's see, 2x plus 2h plus 3 minus 2x minus 3 over the same denominator. And here I see that some good things happen. The 3's will disappear. We've got 3 minus 3. We have 2x minus 2x, so those disappear. And that just leaves me with a 2h in the top and an h in the bottom. And again, since I now have h's there and there, I can divide h by h and get 1. And the reason I can do that, of course, is because h is approaching 0. And since h is approaching 0, h doesn't equal 0, and so I'm not dividing by 0 here. And so this cleans up quite nicely and leaves me with the limit as h approaches 0. And in the numerator, I'm left with a 2. And in the denominator, I'm left with a square root of 2 times x plus h plus 3 and a square root of 2x plus 3. And now I can actually take the limit, which means to substitute for 0. So putting a 0 in for h, I can see that I'm now left with 2 divided by, and I'm going to have the square root of 2x plus 3 coming from the left side, and another one coming from the right side. So I get 2 over 2 times the square root of 2x plus 3, which is just 1 over the square root of 2x plus 3. And that is my derivative. That will give me the slope of my original equation, the slope of the square root of 2x plus 3 at any value of x that I want. Now, if we go back and look at the question's asking us to find the equation of a line tangent to this curve, to f at x, when x equals 3. In order to find the equation of a tangent line, we need two things. We need a point and a slope. We want the tangent at x equals 3, so that means I need to find f at 3, and I need to find f prime at 3. F at 3, well, f at x is the square root of 2x plus 3, so f at 3 is just the square root of 2 times 3 plus 3, which of course is the square root of 9, which is 3. So this tells me that I want the tangent at the point 3, 3. F prime at 3, well, f prime at x, we just said, was 1 over the square root of 2x plus 3. So f prime at 3 must be 1 over the square root of 2 times 3 plus 3, which is 1 over the square root of 9, which is 1/3. And so now I have my point and I have my slope. And with those two things, I can very easily write the equation of a line. So the equation of a tangent line must be y minus 3 over x minus 3 equals my slope, which is 1/3. But I have to be careful. I have to remember that this, although it is a linear type equation, is going to have a hole at the point 3, 3. And we don't want a hole at the point 3, 3. In fact, 3, 3 is the point of tangency, so we know that exists. So we have to move that denominator over, and we're left with our equation, y minus 3 equals 1/3 of x minus 3. We could clean that up and put it into slope-intercept form if we wanted to, but since the question only asks me to get the equation of a line, and I have the equation of a line, I'm finished here. So that's how you do that. I hope this video helps.